Close your eyes and listen. No engines, no runway, just a silver arrow whispering past mountains, so fast that before a plane finishes taxiing, you're already pulling into downtown. In China, the fastest way to cross a country might never leave the ground. This is how the train beats the plane, door to door. Let's count down the 8 breakthroughs making it real. Number 8. Fuxing CR400. Step into the city. Step off in the city. The Fuxing glides at 350 kilometers per hour across a high-speed network that stitches the map together. Beijing to Shanghai, about 4 hours and change, center to center. No airport transfer, no security maze, no baggage carousel. You roll your suitcase off the platform and you're already downtown. Picture the day. You leave your apartment at 7:30, a 10-minute metro ride to the station. Scan your code, find your seat. At 8, the doors close with a sigh. The city slides away. By lunchtime, you're in the heart of your destination. No shuttle buses, no runway queues, no lost hours. Here's the secret. Your clock starts at your door. For trips under roughly 1,200 kilometers, 350 kilometers per hour rail often wins on total time. Frequency helps too. Trains can leave every 5 to 10 minutes on trunk lines, so you leave when you're ready, not when the airline says. It feels like flying, but you never leave the ground. But that's just the beginning. The next platform edges into jet territory. Number 7. CR450. Same silence, more speed. The CR450 is China's next-gen high-speed platform designed to cruise in the 400 to 450 kilometers per hour class on key corridors. Think smoother noses for less drag, lighter bogies, quieter cabins, smarter traction. It's speed without the stress. Tests have already nudged past 450 on dedicated sections. Raised cruise speeds and 1,000-kilometer city pairs collapsed to 2-3 hours. That's the space jets used to dominate, but with trains, you skip the airport overhead. You sit, you sip, you scroll, and the countryside becomes a blur. Why this matters? The moment 400 plus becomes routine, short-haul flights start to sweat. Capacity goes up, delays go down, and the map of what's commutable expands. If that seems futuristic, wait for what's next. A bullet train that thinks for itself. Number 6. Intelligent Fuxing. A train that moves with the precision of a pilot. During the Winter Games corridor, the intelligent Fuxing ran with high-level automated operation, sliding into stations with millimeter accuracy, cruising up to 350 kilometers per hour with a steady hand. Drivers remained on board, but the system did the heavy lifting. Picture the ride, predictive braking that knows the platform before you see it, precise docking so doors line up perfectly with the platform every time. Real-time monitoring that listens to every motor, bolt, and brake. Beijing to Zhengzhou dropped from hours to under 50 minutes, and the experience felt effortless. Why this matters? Automation squeezes minutes out of every stop and curve without touching safety. Precision equals speed, and it worked on a national stage watched by the world. But if steel wheels are the present, magnets are the leap. Now we float. Number 5. Shanghai Maglev. You don't roll, you glide. The Shanghai Maglev has been levitating commuters since 2004, hitting 431 kilometers per hour on a short sprint to Pudong Airport. No wheel friction, just electromagnetic lift and a linear motor shoving you forward like a slingshot. Walk on, sit down, watch the skyline whip by. 7 or 8 minutes later, you're at the terminal. Airline speed, on the ground, every day. Acceleration is fierce. Maintenance is lean. The ride is glass smooth. How this changes the game? It proves you can run jet-level speeds on the ground reliably. It looks like a train, but it moves like a jet on rails. And China's building something even faster, aimed squarely at short-haul air routes. Number 4. 600 km/h Maglev. Now imagine leaving 431 in the rear view. CRCC's 600 km/h Maglev prototype is built for corridors where steel wheels can't keep up. The concept is simple: float, accelerate, arrive, before a plane has finished boarding. At 600, the gap to jet cruise narrows. The station-to-station advantage widens. Think Shanghai, Wuhan, Shenzhen, Xiamen, Beijing to Qingdao. The math flips. When you start downtown and end downtown, a 600 km/h Maglev turns short-haul flight into why fly? The experience changes too. Low noise, no wheel wear, fewer vibration sources, and quick turnarounds. This is the speed at which the ground starts to feel like the sky. From levitation to near airless tunnels, the jump from fast to faster than flight starts here. Number 3. HT Maglev. High-temperature superconductors lock the vehicle to the track like a ghost on rails. Trapped magnetic fields pin the train in space, stable even with no power on board. It's levitation with memory. China's ring tracks and demo vehicles have shown the effect in the real world. Liquid nitrogen-cooled superconductors, permanent magnet rails, a levitation gap that stays steady even if the power flickers. The point isn't just smooth floating, it's control. Strong, stable, and ready for higher speeds with less drag. Why this matters? Stable levitation plus a sealed guideway sets the stage for vacuum tube maglev, where air resistance, the biggest thief of speed, almost disappears. It's the rail system for a world with no air. If that sounds sci-fi, the next program is already building the tube.
Number 2. T-flight tests.
Picture a sleek capsule sprinting through a giant steel vein, air thin to a whisper. CASIC's T-flight program is China's low-vacuum maglev, test tracks, pressure control, and capsules designed to push far past conventional limits. Early reduced pressure runs show exactly what you'd expect when drag goes away: acceleration without turbulence and speed without weather delays. The goal is step by step: longer tubes, higher speeds, smarter safety layers. Pilot lines are targeting 600 plus as they grow, on the path to 4 digits. What it means for you? Center to center, this is how a train starts beating planes where they're strongest. No runway congestion, no holding patterns, just a clean sprint from city to city in a controlled tube. When the air gets thin, trains get fast. And now, the headline, the 4-digit moonshot.
Number 1. T-Flight 1000.
A maglev capsule in a sealed tube, a design target of 1,000 km/h. Long tube test beds in development. This is the concept built to outrun jets, not just compete with them. The sweet spot is 500 to 2,000 kilometers. Picture Beijing to Shanghai in about an hour, door to door. Step out of your apartment at 8 a.m. Metro to the hub. Board in minutes. The capsule slides into the tube. A gentle push, then a smooth rush you feel in your seat, not your stomach. You step off downtown before a plane at the airport even calls boarding Group 2. Frequency is the quiet superpower. Departures like a metro, capacity like an airline. And because you're in a controlled tube, the weather becomes background noise. No lightning delays, no crosswinds, no de-icing holds. It brings the plane's only advantage, cruise speed, down to the ground and erases the time sinks around it. It's the first ground vehicle designed to beat a jet, both on speed and on time. So, is the train really faster than a plane? Let's run the day, side by side. The plane, a 40 to 90-minute ride to a distant airport. A 45 to 60-minute security and boarding routine. A pushback, a taxi, a wait in the departure queue. An hour in the air, a taxi to the gate, a walk, a baggage carousel. Then a 30 to 60-minute ride into town. The train, a short hop to the central station. Scan your code, walk to your seat. Departures every few minutes. No turbulence, no runway backlog, no shuttle bus at the end. You step off into the city you came for. Today, 350 kilometers per hour rail often wins in under about 1,200 kilometers.
At 600, the window widens. At 1,000, vacuum maglev is built to beat short-haul jets outright, center to center. From steel wheels to silent levitation, from city trains to vacuum capsules. This is one climb in one direction, and each step makes the next possible. All these breakthroughs are building one future, ground travel that feels like flight. Recap. 8. Fuxing CR400, 350 kilometers per hour service, center-to-center time killer. 7. CR450, 400 to 450 kilometers per hour class, quieter and more efficient. 6. Intelligent Fuxing, automated precision at 350 kilometers per hour. 5. Shanghai Maglev, 431 kilometers per hour daily levitation. 4. 600 kilometers per hour Maglev, prototype aimed at plane rivaling ground speed. 3. HTS Maglev, superconducting levitation that locks to the track. 2. T-flight tests, low vacuum Maglev pilots, step by step. And 1. T-flight 1000, the 4-digit capsule built to outrun jets. For the first time, the fastest ride across the country might never leave the Earth. The ground is becoming a second sky, quiet, smooth, and breathtaking, with a view out the window. Which would you try first? 600 kilometers per hour Maglev or a 1,000 kilometer per hour capsule? And on what route? Tell us below. If you're ready for more deep dives into the tech that turns trains into time machines, hit subscribe, ring the bell, and share this with someone who's done with airport lines. The next decade will change how we move.